This may be the future of our planet. The skyscrapers of downtown New York City stand in 80 feet of water. Its famous subway system submerged.
Boston, Philadelphia, Washington, Miami, they would all be underwater.
Melting ice has flooded the oceans. The Arctic ice cap is long gone. Severe weather relentlessly assaults the planet.
Record heat, record drought, record flooding. This is not a world we want to get into.
Crop failure, mass migration, riots, extinction. Global warming. Two words that often invoke dire predictions of the planet's future. But is this really our destiny?
This is the most serious of environmental problems. It's the one that we need to solve now.
We head to all corners of the globe.
The size of the population has declined. The future doesn't look good.
Speak with leading scientists.
Coral bleaching events are clearly telling us that reefs are in trouble.
And examine the evidence to find out what global warming really means, and if rising temperatures can truly make a difference between the world we know today and a world we may not recognize tomorrow.
Years ago, climate scientists were discussing whether the Earth was cooling down or warming up. Now, a vast majority of those scientists believe that global warming is real and it's having a dangerous impact on the planet that we inhabit. What caused those scientists to change their minds? What evidence did they uncover? And what have they determined about the future that you need to know?
We start here in the ice fields of Patagonia. Sandwiched in the valleys of the Andes Mountains between Chile and Argentina, the Patagonian ice field is the largest expanse of ice outside of Antarctica and Greenland, covering almost 7,000 square miles and extending all the way to the Pacific Ocean.
When I was here in 1998, this lake was completely full of icebergs. We couldn't get our boat to the ice front, and you can see most of the icebergs now have melted.
Glaciologist Stefan Harrison and his colleagues have studied the ice fields for almost 2 decades. Here, hundreds of glaciers, some more than a half-mile thick, have survived many periods of climate warming since the last ice age ripped the Earth. But in the last 7 years, these glaciers have lost 10% of their mass.
20,000 years ago, this valley was much more covered in ice than it is now. The reason why we think climate change is so significant now, though, it's happening at a historically fast rate.
Rapid melting is not happening just to the glaciers of Patagonia. In the United States, one of the nation's most famous landmarks, northern Montana's Glacier National Park, may soon lose the very thing it was named for.
Some of these glaciers are 5,000 to 8,000 years old, yet they're melting so rapidly they could vanish in my lifetime.
Once, there were more than 150 glaciers here. Today, there are fewer than 40. As these before and after pictures dramatically show, glaciers that took thousands of years to form are disintegrating in only decades. And it's happening from the Andes to Alaska.
I've heard a lot of people say, hey, global warming, bring it on. I live up here in northern Montana. I'll be able to swim in this lake in April.
If all it meant was slightly milder winters in the north, probably a lot of people would be for it. But that's not what's at stake. We're talking about remaking the world in very dangerous ways.
At the eastern end of the Antarctic Peninsula, a massive ice shelf juts into the ocean. Known as Larsen B, this plate of ice has been in deep freeze for the past 12,000 years. But in the summer of 2002, something unprecedented happens. Larsen B completely collapses. A chunk the size of Rhode Island falls into the sea. Scientists are stunned. Something unusual is happening to ice all over the world.
Okay, 1, 2, 3.
Nicely done.
The glaciers of Patagonia are literally melting before Harrison's eyes, carving rivers through the ice, cooling into lakes, and tunneling holes that burrow hundreds of feet into the heart of the glacier. Harrison rappels into one of these holes to get a closer look at what's happening inside the ice.
Wow. The color's amazing.
Harrison is not surprised by what he finds. More water.
You know, this looks like a solid world, but in fact, actually, all the ice here is melting. There's water running through the bottoms of these ice caves. You can hear waterfalls in the background. This is basically a watery landscape, and this ice is actually melting very, very rapidly.
To Dr. Harrison, melting ice is the canary in the coal mine, an undeniable sign that global warming is happening now. But ice also tells scientists something else just as crucial: when global warming has occurred in the past. The ice is a logbook of the Earth's climate going back hundreds of thousands of years.
You can see the ice here is absolutely full of bubbles, and the bubbles were formed when the ice was formed. And of course the bubbles contain atmosphere, oxygen and carbon dioxide.
Like Stefan Harrison, Mark Serres studies ice.
Why don't you lead the way?
Here at the National Snow and Ice Data Center in Boulder, Colorado, scientists have preserved thousands of ice cores drilled from deep in the glaciers of Antarctica and the world's second largest concentration of ice, Greenland.
These are records of past climate, which in the case of Antarctica extend back more than 600,000 years. So really it's recording 600,000 years of Earth's climate history.
Layer after layer of compacted snow contains ancient dust, debris, gas bubbles, all clues to climate behavior. By analyzing this long timeline of climate history, Serres and others can better understand if today's climate behavior is normal or something very different.
Changes that we've seen in the past decade are much too large, much too pronounced now to be simply explained away as just part of a natural cycle. There's something much more fundamental hitting on the climate system now.
In the last 100 years, the Earth's temperature has climbed 1 degree. Could that single degree impact the climate in such dramatic ways? Climate is far from constant. It operates like a complicated machine with many moving parts. Even a slight change in just one of those parts, temperature, sunlight, ocean circulation, can have a domino effect on all the others. So if the temperature goes up or down, it can ripple through the whole system.
To put it into perspective, the depths of the ice ages were separated from the period today by only a few degrees in the global average temperature.
The ice ages, according to biologist Stephen Bacala, were climate changes brought on by natural cycles. Approximately every 100,000 years, the Earth's orbit becomes slightly more elliptical, taking us further from the sun. When that coincides with other cycles, such as periods when the planet tilts away from the sun, it can cool things down.
Those changes trigger a set of mechanisms that cause there to be more or less heat put to different parts of the planet.
It doesn't take much to spawn an ice age, just a small drop in the amount of sunlight reaching the Earth. So had New York City existed 160,000 years ago, it would have been on the edge of an ice pack over a mile high. 30,000 years later, it would have been under 20 feet of water. What we need to know, says Dr. Bacala, is that climate change is not always slow or gradual.
There's a class of almost instantaneous climate change that I call monsters behind the door. I call them monsters because were they to occur today, they would be catastrophic.
Monsters that many scientists fear may be unleashed in the coming decades. January 1, 2006. Across southern Australia, the summer heat blasts its way into the record books. In the capital of Sydney, temperatures top 111 degrees. By the end of January, the most destructive brush fires in 20 years raged throughout the country, killing 9 people. After the hottest year on record, the new year brings only more of the same.
Yeah, I mean, look how hot this is. This is just amazing, isn't it?
Yeah, it is.
It's hot country.
In New South Wales, Fire Chief Russell Rees inspects the damage left by a wildfire during what should be Australia's wet season.
Look how little there is.
The severity of the devastation is surprising and alarming. After 30 years in the fire service, Rees is fighting an enemy he no longer recognizes.
Bushfires are part of the Australian phenomenon. They've been around for millions of years. What's changing is how the fires behave, the frequency of the fires, and the way that they burn and the things that can change during those fires.
After a decade of drought, these grassy hillsides have become the most combustible kind of fuel, deprived of moisture for years. And there's something else that Rees has noticed, something that tells him a greater force is at work than just simply a dry spell.
It's also changing the short-term weather patterns, giving us this volatility, this spikes in the weather that is causing us to go from calm days to very, very blow-up fire condition days, just out of the blue.
Extreme heat. It's not just happening in Australia.
To the weather now, and no surprise, it is awful.
Chicago, 1995. Temperatures over 100 degrees kill 739 people in only 5 days. And in Europe, 2003, more than 30,000 perish when a record-breaking heat wave grips the continent. Of the 21 hottest years on record, 20 have occurred since 1980. There are some people saying, look, the long history of the planet, it's always had spikes, up and down.
Climate has changed throughout Earth's history for natural reasons. The difference is that in the future, climate change will come on much faster than any change in the history of civilization.
How can experts such as Dr. Michael Oppenheimer be so confident that this current warm-up is unusual? The reason can be found back in the Ice Core Laboratory in Boulder. In layer after layer, going back hundreds of thousands of years, scientists can measure tiny samples of atmospheric gases that have been trapped and preserved. And there's one gas in particular that follows the rise and fall of temperature almost perfectly. When temperatures go up, there is more of it. When temperatures go down, there is less. That gas is carbon dioxide, CO2. in analysis after analysis, Serres and his team find something alarming.
We find carbon dioxide concentrations in the atmosphere today are higher than anything we've seen in the past 600,000 years. This is telling us that present-day climate is very unusual.
CO2, carbon dioxide, is not pollution. In fact, it's essential to life on Earth as we know it. Animals exhale it, plants and trees breathe it in. And carbon dioxide plays another vital role on this planet.
It's one of the gases in our atmosphere that helps keep the Earth warm. When the sun's energy hits the Earth, some of it is absorbed and some reflected back into space. CO2 traps more of that heat energy and holds it in the atmosphere.
That's the greenhouse effect, and it's a good thing, because without that natural greenhouse effect, Earth would be about 60 degrees Fahrenheit cooler than it is now. It would be a frozen desert, and humanity would never have developed.
All the greenhouse gases together, CO2, methane, water vapor, nitrous oxide, make up only 1% of our atmosphere. Not much. But the climate history has shown how even slight changes in the amount of those gases, particularly carbon dioxide, can swing the Earth's climate from one extreme to another. And as scientists have discovered, never since human beings first walked the Earth have carbon dioxide levels been this high. The question is, why? This is the Amazon. More than 1.5 million square miles of rainforest, roughly the size of the continental United States. It's famous for its striking beauty and the diversity of life that calls the forest home. The Amazon also plays a less obvious, more critical role in the health of the entire planet. The billions of trees here and in forests around the world absorb carbon dioxide on a massive scale, helping to keep levels in check. Without them, a lot more carbon dioxide would remain in the atmosphere. What we need to know, say Amazon researchers, is that the CO2 now flooding into the atmosphere is beginning to overwhelm the Earth's ability to absorb it. To make matters worse, the Amazon is under attack by loggers, farmers, and drought.
We're looking at what could be the future of much of the Amazon. It's a forest that's burned repeatedly, and the trees that are left are extremely tolerant of drought. They can take a lot of drought.
Daniel Nepstead has spent more than 20 years studying how to best conserve the Amazon, often referred to as the lungs of the planet. 2005 was the driest year Nepstead has ever seen. He believes that the climate is changing here, steering rainfall patterns away from the Amazon. When the rain goes away, so does the rainforest.
Right now is probably the worst time of the day for the tree. It's having the hardest time getting water all the way up from the ground, 30 meters below, to this level. It's 100 feet of vertical draw that these leaves have to do.
What Nepstead wanted to learn was how long the trees of the rainforest could survive these droughts. To find the answer, Nepstead didn't climb trees, he dug. What he found surprised him. Instead of a shallow root system, these trees have the capability to extend roots more than 40 feet down in search of water, making them much more resilient to dry conditions than he ever expected. But Nepstead believes these trees have a tipping point.
even that very deep soil will eventually run out of water. If there's not enough rainfall coming into the rainy season to recharge it, to supply water to the trees during the dry season, when there's very little rainfall, then they'll start to die.
Not only will a large-scale loss of these towering trees destroy a unique ecosystem, it will disrupt the forest's ability to absorb carbon dioxide, and in fact, it may do the reverse, release it. When the trees die and decompose, oxygen in the air mixes with all the carbon stored in their tissues. The result? Carbon dioxide released into the atmosphere.
There's 15 years of global emissions of carbon stored in the trees of the Amazon. So if you nudge that a little bit one way or another, it's going to change the composition of the atmosphere. It's going to make the blanket, which is now thin but getting thicker, grow thicker even faster as carbon dioxide builds up.
Ironically, it was forests such as this from Earth's ancient past that scientists believe are behind the rising carbon dioxide levels overloading the system today. Geologist Bob Spicer explores an open coal mine in China, where the steep walls tell the story of an era in Earth's history, when ancient vegetation was trapped and buried, its carbon preserved and transformed into coal over the course of millions of years.
That's quite a nice little leaf. Sort of a messenger from the past.
55 million years ago, this coal mine, like many places in the world at the time, was a broad, flat swamp covered with trees and plants. When those plants died, there wasn't enough oxygen in the swamp for them to decay properly. They simply sank to the bottom as a thick, carbon-rich mass called peat.
And eventually, that peat surface is covered by other sediments. Sediments upon sediments upon sediments. And the increasing pressure, increasing temperature, changes the peat into coal, what we have here today.
Coal is not the only product made from this kind of geological process. Oil and natural gas started off as ancient microscopic marine organisms, also transformed in much the same way. All that carbon buried for so many years ultimately would be discovered by humans. And they would quickly learn that oil, coal, and natural gas make excellent fuels.
But in the process of burning all of those fossil fuels, we're taking that ancient carbon and converting it into carbon dioxide.
As early as 1896, a Swedish scientist named Svante Arrhenius suspected that burning these fuels on such a massive scale might actually change the atmosphere. But it would take another 50 years for the first pieces of evidence to emerge to back up the theory. In 1957, climatologist Charles Keeling set out to measure the natural rise and fall of carbon dioxide levels as vegetation absorbs it during the spring growth and expels it during fall decomposition. He noticed that the natural ups and downs of the carbon cycle weren't following a straight line. They were actually climbing, which meant more and more CO2 was remaining in the atmosphere each year. His graph documenting the CO2 rise became known as the Keeling curve.
The Keeling curve proved that human beings are increasing the levels of carbon dioxide in the atmosphere, and carbon dioxide is a primary global warming gas.
Fossil fuels that took millions of years to form, we are now burning and releasing as carbon dioxide in just a few decades.
And the effects are irreversible because the gases, once they're emitted, stay in the atmosphere for decades, centuries, even millennia. While we sit here, we're breathing some of the CO2 that was emitted by the first Model T, and some of it will still be here 1,000 years from now. That's the way we're building in an irreversible problem.
The global scientific community no longer questions how we got to this point. It worries that we are pushing the climate to the point of no return. Dr. Nick Lund of the Canadian Wildlife Service is on a return trip to the remote Arctic region of Churchill, Manitoba, along Canada's Hudson Bay. Lund has tracked the polar bear population and its movements here over the past 2 decades in the largest and most comprehensive study of the species ever conducted. His team tranquilizes the bears they find and collects data on each one captured. Their updated records go into the database.
The size of the population has declined from about 1,200 back in the 80s to now it's under 950, so a decline of about 22%, and it's directly linked to early breakup of sea ice.
Polar bears rely on sea ice to survive. For a few short months in spring, the bears hunt on the edges of the melting ice, where seals come up for air. For the bears, this is their last chance to feed before the long summer fast. But the ice is now melting earlier in the year and at a faster pace. The bears simply don't have enough time to hunt all the food they need to survive.
We'll rope the cubs up, and then we'll immobilize each cub by hand. A small amount of the same drug that knocked mom out will knock the cubs out. 12.5 pounds for cub 3. The numbers of bears in the Churchill population are falling as a result of reduced cub survival and juvenile survival. We think that some of these bears are starving. We think that mothers may not provide enough milk for their cubs.
Lund has watched the average weight of these bears decrease by some 15% since the 1980s. Within the next 6 years, female bears may not have enough body fat to reproduce. The chances that these triplets will survive to adulthood, let alone make it to next fall, are slim. They're likely to become another statistic in Lund's database of a species on its way to extinction.
It makes me sad to think that I might be the last person working on this population and be known as a polar bear historian.
It wasn't until recently that scientists even worried about Arctic sea ice, which naturally shrinks and expands each year as the seasons change. In 1979, the sea ice covered almost 1.7 billion acres. That's about the size of the United States. But in the last 2 decades alone, the Arctic has lost an area roughly twice the size of Texas. At first, scientists debated the cause, but few linked global warming and mankind's carbon dioxide emissions to that retreat.
We had certainly noticed that the sea ice cover through about the year 2000 had been on a general decline, but it seemed that this could be fairly easily explained by just natural cycles in the climate system. For example, changes in the weather patterns.
Those natural cycles should have cooled the Arctic down by now, but the warming has only accelerated. Climatologists such as Dr. Serres are now convinced that greenhouse gases such as carbon dioxide are behind the sweeping changes that they've seen here. If the melting continues at this rate, by 2060, computer models predict that there will be no sea ice at all during the Arctic summer.
The potential extinction of a species such as the polar bear is just one reason to worry about melting ice. About 10% of the Earth's surface is covered by ice, most of that in the polar regions. But if enough of that ice melts, the seas will rise dramatically, and the results will be calamitous.
Scientists are keeping a watchful eye on the largest concentrations of ice on the planet, Greenland and Antarctica. More than 75% of the Earth's fresh water is locked up in these two places. In the north, the Greenland ice sheet, almost 775,000 square miles in size, has been rapidly shrinking.
The rate of outflow of icebergs from Greenland has doubled and then doubled again over the last 15 years. And if that happens a couple of more times, we may get to a point where the ice sheet really just begins to collapse.
Scientists believe that if the current warming continues, the oceans will rise by as much as 3 feet by the end of the century. The Greenland ice sheet will contribute very little to that increase, but if temperatures hit the 4-degree mark, scientists worry that it will trigger irreversible runaway melting of the ice sheets at both poles.
The Greenland ice cap contains an equivalent of about 23 feet of sea level rise. The West Antarctic ice sheet contains an equivalent of about 20 feet. If we lose a significant part of either of them, coastal civilization as we know it will disappear.
In the coming centuries, New York City could be abandoned, its famous landmarks lost to the sea.
Boston, Philadelphia, Washington, Miami, they would all be underwater. In fact, the entire state of Florida.
This could be the view of Miami, now 50 miles out to sea. Across the Atlantic, the water would reach all the way to central London. It would be the same story for coastal cities all over the world. And low-lying countries such as Bangladesh, with much of its landmass at sea level, would be almost wiped off the map.
How long would that take, that kind of apocalypse of water, if you will?
Well, the temperature change would be this century, and how long would it take the ice sheets to respond? That could be 50 years from now, could be 100 years from now, but it's not 1,000 years from now.
For many who live in the South Pacific, the encroaching sea is already at their doorstep. In February 2006, on the tiny island country of Tuvalu in the South Pacific, residents brace for what may be the highest tide they've ever seen. Predicted to reach 11 feet, the people here could be forced to flee to higher ground until that tide recedes. Tuvalu is no stranger to flooding, plagued by the occasional storm surge and extreme high tides. But this time, things are different. Tuvalu, only 16 feet above sea level at its highest point, is now in danger of becoming a modern-day Atlantis. threatened by the rising ocean around it.
The high tide on Tuesday was very shocking to me to see that the tide was really high compared to the past years.
Until recently, says resident Diana Samey, higher than normal tides appeared regularly, but briefly in January or February. Now, these abnormally high tides are occurring for almost half a year. The flooding is more severe, sustained, and widespread.
Added on to that, it's the erosion. Our islands have been eroded very badly, to the extent that some of our small islets have disappeared and some are on the way to disappear.
Like most residents, Helia Vave, Tuvalu's senior meteorologist, can only watch helplessly as her country drowns. The islands of the South Pacific are made of porous limestone and coral rock, and high tides actually swell through the ground, flooding Tuvalu from the inside out. To build barrier walls against the ocean would be pointless.
We're so definite that things won't get better. Things are just gonna get worse and worse.
If the oceans continue to rise, many of these small island countries will simply vanish into the sea. Scientists are in a race to figure out how quickly that might happen. Sea level can be a difficult thing to measure, and there are few records before the 20th century to help scientists measure how sea levels have changed in the last few hundred years. One of the oldest tide gauges ever found is on the Australian island of Tasmania, in an unlikely place called the Isle of the Dead.
We have very few long-term records of sea level, so this does fill a much-needed gap in our understanding of sea level rise in this part of the world.
Records from the gauge, carved in this rock, show that since the 1840s, there's been a sea level rise of 6 inches. It's one of the few long-term records that confirms what scientists believe is happening worldwide. In the last 100 years or so, the planet's oceans have risen anywhere from 4 to 10 inches. But the rising water isn't just a result of the tremendous volume of ice melting into the oceans. Scientists are convinced that global warming is raising the temperature of the ocean as well, and that can have a dramatic influence on sea levels.
A side effect of that warmer ocean is the thermal expansion of ocean waters. That thermal expansion is causing the sea level to rise.
When ocean temperatures warm, the water literally expands, taking up more space. This thermal expansion alone may account for more than half of the rise in the sea level in the last century. The projected rise of 3 feet by the end of this century will do more than threaten cities such as New York and London. The beach, the very reason we go to the coast, may disappear before our eyes.
For every foot of vertical sea level rise along the East Coast, a typical beach loses about 100 feet inland due to submersion and erosion.
In the U.S. alone, this erosion could destroy more than a quarter of all structures built within 500 feet of the ocean and wipe out more than half of our coastal wetlands. But it's the rising temperature of the oceans that scientists fear could impact coastal communities the most. Like the air, it has also climbed 1 degree. That may not seem like much, but when the entire ocean gets warmer, the atmosphere reacts, resulting in all kinds of dramatic and dangerous weather around the globe. There's no better example of this often stormy relationship between the ocean and the atmosphere than a phenomenon called El Nino. When conditions are right, a giant stream of warm water floods into the Pacific Ocean. Normally, this superheated water is pushed westward and trapped against the coast of Australia by powerful trade winds. But when those winds let up and change direction, all that warm water barrels eastward. El Nino is an example of how heat stored in the ocean not only causes the water to expand, but how it can turn weather upside down all over the world. It changes rainfall patterns, causes floods in usually dry places and drought in normally rainy locations.
Is El Nino a manifestation of global warming?
We don't know exactly what the effect of global warming on El Nino will be, but one theory has it that it will essentially turn the Pacific Ocean into a permanent El Nino state, and that would send echoes around the world and give us a quite different climate.
What scientists are sure of is that the tropical oceans are indeed warming and rising worldwide. And the heat stored in those waters provides even more fuel for one of the most devastating forces of nature, a hurricane. The 2005 hurricane season, a year that didn't simply break records, it smashed them. 28 officially designated storms, including the most deadly to hit the U.S. in almost 75 years. On August 29th, Katrina slams into the coasts of Louisiana, Mississippi, and Alabama. It is the most devastating hurricane to ever hit the Gulf states. Reaching speeds of 175 miles an hour and ravaging 100 miles of coastline. Then, on top of the wind and driving rain, more water. Katrina's storm surge is so powerful, it breaks through the levees of New Orleans, the only city in the United States built below sea level. The barriers that had withstood storm after storm for the last 40 years were no match for Katrina. % of the city floods. More than 1,000 are killed. The sheer destructiveness of the hurricane has become the turning point for many scientists. Although they can't say that one particular hurricane is caused by global warming, many scientists are now making the connections between global warming, rising sea temperatures, and the strength of hurricanes. Greg Holland of the National Center for Atmospheric Research is not surprised by Katrina's ferocity. 2005 also set the record for the warmest temperatures in the Gulf of Mexico, where Katrina spun into a monster.
But it's here in the Gulf of Mexico that they really get going and develop their full destructive power.
As energy from the warm ocean is drawn up into the atmosphere, it condenses into clouds. Winds grow stronger and start to spiral. More air and moisture are drawn upward in the vortex. A self-feeding cycle of frightening power is born.
The really destructive winds in a hurricane extend out for 100 miles or more, and it is so powerful that it could run the entire electric grid of the United States for several weeks.
But like the El Nino phenomenon, it's tough for scientists to separate natural hurricane cycles from the effects of global warming. Right now, it's a hot debate among scientists because we're in a 30-year natural cycle of hurricane hyperactivity. Holland believes it's not the frequency of hurricanes that warmer temperatures are affecting, it's the intensity.
We went back and we got all of the tropical cyclone data for the entire globe going back to 1970. And lo and behold,